video will cover section 3.4. That includes the product and quotient rules. And those two formulas, you guys wrote them down last class, and they were like 3.10 and 3.11, something like that. So I really wish I had the time to prove both of them, but I don't. Maybe next semester if the class changes or but maybe next year. I don't see that changing anytime soon. So what we're going to do here is use all the rules that we learned previously, but also include the two new ones, product and quotient rules. So just to review them quickly, and you see different notation, and it depends on the book. So the one that we're using, it will be the product rule. You have so the formula we have is you have the function f times the function g, and then you try to get the derivative of that. You're going to have the derivative of f times the original function of g, and then you're going to add the original function of f times the derivative of g. So we're going to be using that formula for the second part of the problem, which is this one right here. Okay? So first, let's see, what is the derivative of 6x by using the power rule? 6. So 6. Now here we have two functions, one of them, so I'm going to call them, I'm not going to call them f and g. Sometimes books use this notation. You have u, b, u is a function, b is another function. Instead of using f and g, I'm going to use that. And if you take the derivative of that, it's going to be the derivative of u times b plus u times the derivative of b. And so the reason I like that notation is because the problem itself is already, the function is already called f. So I don't want to have like a lot of f and g. So we're going to keep that, and now we're going to make a substitution. So u will be the function 11x. So because of that, u prime will be 11. Then the other function, function b, is going to be the e to the 5x. So b prime is going to be 5e to the 5x. Okay, and then, so now we're going to apply this part to the rest of our f prime formula. And so that is going to be following the notation here. So u prime is 11. And a plus is this plus from here. So plus 11. And then function b, which is e to the 5x. And then plus function u, which is 11x, times b prime, which is 5e to the 5x. Now, you might want to simplify a little bit. So this could be 6 plus 11e to the 5x, and then times 55, well, I'm sorry, not times, but plus 55x e to the 5x. So try to enter that. Okay, so you guys can see I got the question right. So let me erase everything now.
Or if you didn't.
Oh, that's okay. We're not perfect. Okay, one.
Remember what I said last year? When you said that? Well, I'm not perfect, obviously. I thought you would give me PBIS form in that moment. I was like ready for it.
Okay, so next one, we have our first function here is going to be, and I'm just going to start using u, okay, uv. So u is the polynomial 12x squared minus 24x plus 24. So because of that, u prime is going to be,
Wait, is it multiplied by e to the x?
which one?
Why?
Okay, so you have two functions multiplying each other. One is the polynomial and the other one is e to the x. Yes. So then from here, b, the other function will be e to the x. And because of that, b prime will be also e to the x.
Oh, okay.
Okay? No, it's okay. So then let's get the derivative of u prime. Well, the derivative of u. So that will be 24x minus 24. Yeah, you guys agree? Okay, so now we're going to use the formula. And so we're going to be using u prime b plus u b prime. Okay, so now we just need to arrange them nicely. So this will be, for u prime, we have it here. So it will be 24x minus 24 times, and now we need b, that was e to the x. Then we will have a plus that comes here from the formula. We need function u, which will be the polynomial 12x squared minus 24x plus 24 times b prime, and b prime is also e to the x. Okay. Try to enter it like that. I don't think we have to distribute, but yeah, that would be correct. Math homework, not science or English or whatever.
It's like conversion is part of math.
Not calculus.
Sorry, I'm sorry.
Why is e to the x so special? Like, the derivative is e to the x. Why? Does it work with like 2 to the x? Like 2 to the x? The derivative of 2 to the x is 2 to the x?
No.
Well, what? What's so special about e though?
Well, e is a very special number. Natural number.
Why?
Why the letters?
Yeah,
Why can't it be K for
like-
me?
I think that e is used like more than pi. I don't know. Okay, good job. You're doing such a great job. Okay, next question. Come on. Oh, let me erase something.
Yeah, 8% done. Go.
I'm gonna forget my glasses from now on purpose.
Okay. I was gonna have you guys do like a matching activity, but we'll do that when you guys come back and you're lazy and you don't want to do it. Okay, next one. Next one. We're going to do the same thing. So in this case, u is going to be 3x squared minus 9. U prime is going to be 6x. That's it. B is going to be 4x squared minus 9x plus 4. Make sure you guys are using your own formula. And then B prime is 8x minus 9. Okay. So now we're going to follow the formula, and I would suggest that you, every time you use it, you write it down. So u prime b plus u b prime. Oh yeah, you do that out. Or in plastic. Okay, so the next problem, we're going to find the product rule to find the derivative of the given function. That will be part A. And for part B, we're going to find the derivative by expanding the product first. So let's just expand the product first. So just write this somewhere on your notes. And so here I'm going to multiply x times 4x. That will be 4x squared. Then I'm going to multiply x times 2. So that will be plus 2x. And then we multiply negative 6 times 4x. So that will be negative 24x. And then we'll multiply negative 6 times positive 2, so that would be negative 12. Combine like terms, so that would be 4x squared minus 22x minus 12. And so if that, we know that is our function, not in factor form, but in a distributive form, I guess. If we take the derivative, we can just use the power rule, so it will be 2 times 4, so 8x minus 22. So that is pretty much the answer of part B. But if you notice, they want you to do something with it, like factor. Okay. So we could say, if we factor out a 2, so this is the derivative. Wait, okay. We could factor out a 2, and then it will be 4x minus 11. So that's not what we have there. Oh, okay. Wait a second, I'm getting confused. Okay, so ignore everything I said, Marco, if you were watching.
If you
Okay, let's just go like part A first. So part A says use the product rule. Okay, so let's do that. So if we say U is the first binomial, so it's x minus 6, U prime will be 1. And then we have the other function, the other binomial is 4x plus 2, so B prime will be 4, and that's it. So then the derivative, if we follow the formula, which is U prime V plus UV prime, then it's going to be, you start with U prime, which is 1, right, from here, times B, which is 4x minus 2 in my case, plus U, and U is the binomial x minus 6, times B prime, which is 4. Okay. 4. Now, the way they have that, let me see, if we distribute, we'll get 4x minus 2 plus, we're going to distribute this 4, so 4x minus 24.
It doesn't want you to distribute.
I know, but it's like in a weird form.
I'm just not gonna listen to it. Go Miss Bevin. Don't take it.
Oh, no, it's this one.
Yeah.
Okay, I'm sorry.
I'm sorry. The V
Okay,
prime and the U
yes.
prime.
So let's do that, Alejandro. So there, enter a 1. So that would be U prime.
It shouldn't it be 4? Because that.
Oh yeah, I'm sorry, that would be the
yes.
4. That would be the 4. Thank God I don't have to do this homework. And that would be the 1. Right there.
This doesn't make me very.
Very what? You know what, guys? Most of what you guys learn, it's like when you learn on your own.
I was even get mad. I was like, guys, no, I'm okay with your homework.
Well done. Woo. Okay, so the problem was that we didn't have to simplify. We just had to enter the constants 1 and 4, but they were in reverse order. And actually, that's a very important fact of the product rule, that since we're adding, it doesn't really matter if we take U V prime plus U prime V. It doesn't matter because addition is commutative, meaning you change the order, it doesn't, if you change the order, it's not going to affect the result. Yeah? Are you guys Following me? And that's very important because when look at the quotient rule on the board, during 3.8. 3.8, so you guys see there's a minus there. So in that case, it's going to be very important when you do your substitution and you set up your answer. I personally like to use product rule more. But, you know, that's just my thing. Okay, so part B, it says expand the product, so that's what we did here. Thank you, Alejandro. You're a very good assistant. And then if you use either approach, the derivative, I mean, you could just enter from here. F prime would be 8x minus 22. Well done.
Thank you.
Does anyone need assistance with their own question? Your life? So do I. So problem number 6 from your homework, we're going to use the quotient rule for the first time. And so I'm going to write it in terms of u and v. So if we have a function such as u divided by v, the derivative of that is going to be d u prime minus u
D prime.
v prime divided by the denominator
UV.
v to the power 2. Not the derivative, just the function. So let's assign here. So u will be the numerator 6x minus 7. U prime will be 6. Then we have v is x minus 7, and v prime will be
1.
So following the formula, we're going to have first x minus 7 times u prime, and u prime is 6. Then we have a minus. That's very important. You guys remember that. Minus. And then u will be 6x minus 7 with function v prime being 1 over v squared. So that
1.
will be x minus 7
Oh.
squared.
9.
So I'm going to just distribute a little bit. So it would be, let's say, 6x minus 42 minus 6x plus 7. Remember, the negative sign gets distributed here. And it's just transformed, so it's fine. From here, you could actually take 6x minus 6x, combine the, and then the bottom, we have x minus 7 squared. On the bottom, we're going to have negative, what would that be, 35? Oh. Okay?
Yes.
Thanks. Over x minus 7 squared. Oh. You just text it.
Oh, okay.
Okay, so check.
Yes.
Yay! Good job.
Thank you.
Okay, so let's go ahead and skip this one because it's just similar. Let me look at the next one. Let's try that one. Well, it's pretty easy as well. Let's look at the next.
Ooh.
How about that? Yes?
Yes.
What is that?
Let's try that one. Okay, that's going to need like product rule, or we could use quotient rule, whatever you want. Well, if we distribute it, it will just look the same. Another form of it will be something like by e to the x. Because if the exponent is negative, we can bring it to the bottom. So let's go ahead and use the quotient rule here. So u will be the square root of x, or x to the 1/2. You know that. U prime will be just 1/2 of x to the power negative 1/2. Why is it to the power negative 1/2?
Because that's what the square is.
Well, 1/2 positive, yes.
Oh, that's what like -1 will be.
So 1/2 minus 1. Very good. So don't forget to do that, okay? When you're using the power rule, you have to subtract 1 from the exponent. That's like a common mistake. Okay, and then our other function is going to be b is the x, and b prime is also e to the x.
Could you explain again the u?
The u prime?
Yeah.
Okay, so u was the numerator, right? So the square root of x, remember the index, we don't see it, but we know it's a 2.
Yeah.
So the denominator of the exponent, it becomes that the number. So using the power rule, it will be 1/2 times the coefficient here, 1. So that's why I have 1/2.
Oh, okay.
And then it's x, and remember, if you look right there, well, 3.3, take my word for it, you have to subtract 1 from the exponent. So it's 1/2 minus 1. So it will be 1/2 minus 2/2. So it will be negative 1/2.
Okay.
Yeah?
Yes.
Okay?
Thank you.
All right. Now that one could also be written as, let's see, we could say 1/2, and then we could have the x to the power 1/2 here, or we could also say 1/2 square root of x. That's probably how you will see it most of the time. Okay, so now let's do our u and v substitution. So remember, it's going to be bu prime minus v prime u over v squared. Okay, and so we start substitution. So we start with e to the x times u prime, and u prime is all of this here. So it will be 1, 2 square root of x
Minus the same thing.
Minus v prime, so that will be e to the x also. Times u, and u was just the square root of x. And then what am I forgetting in the formula?
Over v squared.
Correct. So that was what?
X squared.
E to the x, and then remember, if we square that, what should I do with the x and the 2? Multiply them. So e to the
2x.
Now here, hold on, Alejandro. One thing you can do is write the e to the x here instead of the 1.
Where?
Like this, like e to the x over 2 square root of x.
Oh, okay.
And then minus e to the x times square root of x. And then don't forget the denominator. Yeah. Sometimes it's not that hard to write them down, but to enter them, you have to be very
Why don't you
careful.
ever just press like the control up arrow, Alex? Like control 6, you know, to press that button. That's just me.
We're gonna pause the video. This might take a while. Okay, so after 20 minutes, the answer.
Wrong.
Oh, rejected.
I feel accomplished.
Go ahead, next question. Let me erase everything.
Well, I typed up like a video. Where you should be proud of it. Quotient would be proud.
Okay.
At a good roast.
Now let's see what we have here. So this function here, we could either do that, or we could use the quotient rule by having a rational function like that. Because we have this exponent of a negative
Exponent only applies to 3t minus 3?
Correct. Now, personally, I prefer to use product rule all the time.
Really?
Yes. I love product rule.
Maybe yes, let's go.
Product rule.
Yeah, just for the partial.
But you know what? Let's not.
What? But you said.
I don't want to, because then I will have to use chain rule, and you guys don't know chain rule yet. So, moving on. So, let's just use quotient. That's too easy now. So, u is 5t minus 1, u prime is 5, b is 3t minus 3, v prime is
3.
So, we're going to use u prime minus b prime u over b squared. And so I'm going to write one. So it is 3t minus 3 times u prime, which is 5, minus b prime is 3 times u, which is 5t minus 1. And then we divide everything by
B squared.
3 squared, which is?
3t minus
9.
3.
Oh, no, I'm sorry, not b prime. So it's actually the 3t minus 3
You have to distribute two.
squared. Say that again?
You have to distribute two.
Let's try it like that.
So you do it wrong.
Because I don't see anything that says distribute. And actually, on the AP exam, you don't have to distribute. Oh, okay. So what I did is I just took the whole thing to the bottom here, and then the exponent becomes positive 1.
Oh, okay. But like, I thought they
No.
Need all the line.
No, only the first factor. If it was to all the factors, then there would be like a dot.
Oh. It's like the
Why?
parentheses.
Drum roll. Thank you. Thank you, miss.
Yes, that's
Okay, so I think you guys are okay with that. Let's look for something more challenging. Okay, so now this one is just a little different because we're going to find the equation of the tangent line. Now, let me remind you that the tangent line is a line, right? That is going to be touching the graph at one single point. So since we're talking about a line, we are going to need this formula. This formula, you will use it a lot in your exams. So if you ever want to get a tattoo of a math formula, I will encourage you to get that one.
Can we get extra credit for this?
No.
Can we use it for the AP test?
No. I don't know. That might get you in trouble. Okay. So I'm gonna have to edit that video. Okay. So let's just use quotient rule quickly. But then they want us to find that equation right there. So they don't want us to find the equation of the derivative. They want us to find the equation of the tangent line.
So it's going to find the derivative anyways.
Yes. So, but it's going to be like a 2-3 step problem. Okay? So then u is 7x, u prime is 7, v is x minus 1, and v prime is 1.
Change. Oh.
Okay, fine. So 7x, and then x minus 1. Yeah. Okay, so we use the quotient rule, which is vu prime minus v prime u over v squared. So it's going to be x minus 1 times 7 minus 1 times q, which is 7. And all of that over b squared, so it's x minus 1 squared. This is all 1.
Wait, so did we have to distribute on the last one? No, right?
Nope. And it's the same with the AP exam. You don't have to distribute if it's a free response. But if it is a multiple choice, you still need to know like how the answers could be equivalent. As if you don't distribute or if you distribute. Because the multiple choice could be either way. Okay, so let's see. So this is just the equation of y prime. Right? Correct. So now we need to find the slope right here. To find that, we're going to have to plug in 2 into y prime. So if we do that, it will be a 2 here and here. Oops, and this is multiplying, okay? And here, right? So we're going to have something like 2 minus 1, that is 1. 1 times 7 minus 1 times 7 times 2 is 14. And then on the bottom, we're going to have 2 minus 1 is 1. 1 squared is just 1. So that's good. 7 minus 14, so negative 7. That number right there is just the slope of the tangent line for that particular x value. Okay? So right here, this m will get replaced with negative 7. Now, this is just x for the variable. This is just y. Now, where are we going to get x sub 1 and x sub 2?
We can plug in an x for the original equation and then get a y.
Very nice. So, what is the x?
Oh, can we use 0?
Well, what about this one?
Okay, we can use
Yeah,
0.
we actually have to use that one because that's what the tangent line they want, at 2. But yes, we can find the tangent line at any x value that you have here, then that would be the one we use, right? So now if we, like Aya said, we're going to have to substitute that x value into the original to find the y value, the one that we need here. Yes? Not in the derivative, but in the original equation.
This one's just going to be 14.
Yeah.
So it will be 7 times 2 over 2 minus 1, which is 1. Yes, that will be 14. So we put a 14 here. And let's see, they want us to enter it in y equals mx plus b. So we're going to have to simplify a little bit here. So let's see, y minus 14 is equal to negative 7x plus 14. So y is equal to negative 7x plus 28.
That's it?
Yep. Wait. You got lost?
That's because you're supposed to.
That was cool.
Okay, don't switch question yet, okay?
Wait, how did you get 14?
How did I get 14?
You plugged in the 2 into the original
Why do
equation.
we get the 8?
The A was given.
No, the 8.
8.
What 8?
We were substituting into the equation that you erased.
This one?
Yeah.
I didn't have an 8.
That's a 2. I think.
It was a 2, it's not an 8.
It was a 2. It was a 7 times 2.
Uh,
So, do you have the one with the variables?
because
You got it?
that was
No, it was a 2 and a 7. It was a 2 and a 7, but they were multiplying, so the parentheses made the 7 look like an 8. Or the 2.
It's because I organized it.
Where'd you get this?
Like I put
Which
it
one?
from the ground side here. I have it in graphic.
For the next part, just graph it and make sure that you change your settings. So what it means here is that the minimum x will be negative 10, the maximum x will be 2, and then the intervals will be 2.
Oh.
That's what it means. So how do you do that on yours? You go to menu, window settings, or document settings or something like that, and then you change the x. Wait, Kayla.
Menu, window settings.
Yeah. What do it? Like, remember how you go to change to gradient?
It's menu for what, but I don't remember the.
I'm sorry. Yes, I'm confused. You're in the graphing section. You go to menu, and then you go to window zoom, and then
then select-
window settings. And then you can change that. All right. Let me just see quickly the rest of the questions, Alejandro. Just click on the arrow. That's okay. We'll go back. That one is same thing. You have to get the derivative, and then you have to use the point slope, the y minus y1, the one that you might get it to do, maybe a temporary one.
Just for the AP test.
Sure. Okay, let's do this one. It has a negative exponent. You could just use the power rule as well. So that would be negative 80 x to the power negative 5. Don't check it. Just go to the next one.
Oh, come on.
Can we take?
Yeah, sure. That's easy. In that case, let me show you guys a quick trick to this one.
Oh, to
That or the other one. This one. So you could do the following: 30 x to the power negative 7. So that you don't have to use quotient rule, and you can just use power rule.
Ah, sweet.
Okay. Keep going. So here you will do the same thing, take the derivative of each, and then for this last one, you could use negative 7 to the x to the power negative 4. Okay? All right, and I think that's it. We'll stop here. Oh, wait.
Just differentiate the function.
Find the derivative.
Okay.
Yes. Just different ways to say it. The only one you have to be careful of is when they ask for specifically for the equation of the tangent. That would be the toughest.
Yeah, that's why I was just like looking at it.
No, it's not
Okay,
that.
so just to clarify,
It's not that hard.
So, but you do this on your own and like, don't just so.
Yeah.
Don't use the x
Yeah.
point.
I can do this.
You can do this.
Correct.
Yeah.
Point that you're looking at.
Alejandro, wait, go back to 24 so I can give you guys a quick hint.
Okay.
On 24.
I'll tell you
Because that's the toughest of all. If you can do that one, you can do them all. So what I would suggest you do here is you distribute here.
Okay.
You're going to get a polynomial of third degree. And then you could use quotient rule.
Instead of having to do 2 parts.
Correct. Alright, so make sure you guys do your homework.
Right, you have to quickly.
Yes.
Okay.